Okay, again, good morning or good afternoon, everybody. Welcome to Math 1432 Calculus 2. I'm Neil Jerome A. Agargin, and I'm going to be your teaching assistant for this semester. I'm going to handle this lab session. We meet from 12 to 1 every Monday, Wednesday, and Friday here in the lab meeting. So I will be posting. I'll be scheduling the meetings via the calendar, and you're gonna see the same thing every Monday, Wednesday, and Friday. If you go to the live lab meetings channel of our team, so you can see there the link. That's essentially the same place that you went to today in order to enter this meeting. So I'll do that every day, probably an hour before our class or a couple of hours before our class. If you need to contact me during off hours, you can use the following contact information. So you can use my CougarNet email address. So this is the same email address that you see if you right click on my DP on our MS Teams. So that's where you will be diverted to write an email. Or you can also use this alternative work email that I have. So if you have some urgent questions, if you have some problems and you won't be able to attend the lab, or you have some urgent questions, so just send them to me via these email addresses. I'll try to answer them as soon as possible. Especially if you send an email before 9 p.m. It's just a thing about me. I usually veer off social media and all my communication stuff after 9 p.m. in the evening. But if you'll be lucky, if you send me an email after those hours, and then you can be lucky if I take a pic on these platforms. But otherwise, after 9 p.m., expect an answer the following day. All right. And then from time to time, we'll have some materials uploaded for the class, or actually at least the worksheets that we will discuss in the lab, along with the annotated worksheets that we produced after every meeting and the video recording of the lab session, so that in case you were not able to attend the lab meeting, you can rewatch these videos, and I'll be collecting them into a web page in my website. So here is my website. You can visit it for a collection of our materials from this class. You can navigate through this website, but I also included the link to my webpage for this particular class on top of the lab meetings channel for our MS team. So if you go to the lab meetings channel of MS Teams, go to the top tabs. You can see one of them says Neil's website. You can click on it and you will be directed to the web page I created for this class. You can also access that page if by using this link for my website. So for instance, I click on it. Yeah, you'll be directed to my personal web page here. There's a lot of things here, my research, some of my hobbies, personal stuff. I guess the most uh, relevant to you is my oh, you can't see anything. Nicholas, how about the others? Can you see my screen?
I can see it.
Okay, good. This is a common problem with MS Teams. Usually those who came in late after I started sharing my screen cannot see my screen. So yeah, that's why I usually start sharing my screen a couple of minutes after we start. Yeah, try Nicholas to rejoin. Otherwise, I'm gonna restart my screen sharing. This is a common glitch in MS Teams, right? But yeah, while waiting for those who can't see my screen, kindly rejoin and let me know if the problem persists. So if you go to my website, you can see a bunch of stuff, but the most relevant would be the teaching tab here. And under teaching, near the top of the page, you can see here my Calculus 1 and Calculus 2 links. All right, so Nicholas can't see, so let me just restart my screen sharing. Yeah, don't worry, Nicholas, it's fine. So if there are some glitches like that, let me know in the chat so we can address the problem right away. Okay. So let me try it again. Okay, let's try this one. Okay, so I hope you guys see it now too. So I am on my website now. Okay, great. Yeah. So if you go to my teaching webpage, you see here some links. The one that is important. Yeah, it's still loading. Still black for now. Let me see what's the problem here. Hold on. Still just black or so let's see what's the problem now. So hold on. Let me try it again. Okay, so I stopped sharing my screen, so you will not be seeing anything. Let me just restart it. It might also be due to some internet connectivity, but I'm at the university right now at my office, so internet should be good. Okay, so now can you see, guys, worksheet number 1 on my screen containing my name?
Yeah, it's working now.
Okay, great. So
Yeah,
again,
it
this
was
is
a
my web.
little bit slow before.
Let's do it over again. Okay. Okay, still loading. Okay, there we go. That's my personal website. Go to the teaching tab. Okay. And then you can see here Math 1432 Labs 04. And here's where I will upload materials for this class. So right now, all it contains is worksheet number 1, review of integration. That's what we will be discussing today. So there's only a blank copy. So that means you can take this worksheet, download it, and then try to answer it on your own. There are no answers yet on this, but I guess this is the same file that you have in CASA, the review topic that Dr. Almas provided you, the review worksheet. So it's the same. I just added a page that contains my info. But as we go along in the semester, I'll populate this with some files. At least I will upload annotated worksheets. So during the lab sessions, we will be answering some problems from the worksheets. So I'll write something on a PDF file. I'll save it and I'll upload those with my notes in the same web page under the tab annotated worksheets. So you can take a look at it, review what we did in class, and then yeah, you can go over my solution again and see if everything makes sense and so on. So that will be available here. Also, I am recording all our lab sessions. So the video recordings, links to the video recordings will also be uploaded here in this web page. So you can bookmark this one. Or again, you can also find this in our lab meetings channel. If you go to the top of the page, you can see Neil's website there. If you click on that, you should be diverted to this web page. All right. So you can see the files available for the class on this web page, right? But another advantage of going through my web page is you will have access to other materials available here. Like last semester, I taught two classes, two Calculus 1 classes. So if there are some topics from Calculus 1 that you think you need to review, or there are some things that you want some extra practice on prerequisite topics from Cal 1. So you can click one of this Calculus 1 links. Say I click Lab 26. Okay. And then you'll be diverted to the files repository I have over here. You see, I have all my lab meeting recordings here and the annotated worksheets or class notes that we produced after every lab meeting. So this usually contains all the answers to the worksheets that we worked on and the annotated versions, right? So I can paste a link of my website on the on the chat. Oh, hold on, that's for lab 2. This is lab 4. So hold on, I posted the wrong. I posted the wrong link. Let's see. Hold on, guys. Okay. So this is the right link. This would be for lab 4. We are under lab number 4. So yeah, there we go. That's my web page for lab number 4. You can see it on the meeting chat. All right. Okay. I see somebody raising his or her hand. Yeah, Nicholas.
I had a question.
What's
Before
up?
these work. Oh,
Do
sorry.
you have any question?
Yeah. Can you hear me properly? Hello.
Hold on, Nicholas. My speakers are off. Okay. Yeah. Hi, Nicholas. Do you have some questions?
Are you able to hear me now?
Oh yeah, yeah. Mhm.
Okay. This may sound like a dumb question. These worksheets are for helping us tutor, right? We don't have to turn anything in.
Yeah, that's correct. These are
Okay.
supplementary materials. They are not graded. You don't need to turn them in, but I highly encourage you to at least take a look at this, browse through this,
Mhm.
see if you can answer those problems. And then the point is, I'll be uploading them some time ahead of the lab meeting. So if you find a problem that looks interesting or looks hard, you can let me know in advance so we can focus the lab on answering such a problem, right?
And I had another question because Dr. Almus didn't really talk about this.
Mhm.
We won't be having any poppers in here, will we?
Yeah, we won't have any poppers, no lab quizzes. As
Okay.
far as I know, that's the last instruction I heard from Dr. Almas. We won't have poppers, we won't have quizzes on the lab. So basically, treat the lab as something that is a supplementary venue for discussing the topics introduced in the lecture. So, but having said that, you are still highly encouraged to attend the lectures so you can interact with me, ask questions that you might have, because the lecture, you have hundreds of students there, and you might not have the opportunity to ask her questions, or maybe you're just too shy to ask questions there. But in the lab, I encourage you to ask questions, no matter how dumb you think they are, or too naive they are. So for me, there's no stupid questions. Just ask me your questions, and I'll try to answer them the best way I can. All right.
All right. Thank you very much.
Okay. Other
Hi,
questions?
I was just gonna ask, so
Uh-huh.
how are we gonna get graded in this class since there are no poppers at all?
Mhm.
And like, how will attendance work?
Okay, the thing is that though there are no poppers or quizzes in the lab, there are some assignments that you need to submit via CASA. So there are online quizzes, there are written homeworks to be submitted, and the lab TAs will be grading them. So yeah, there are no live, there are no graded things on the live lab meetings, but definitely there are some assessment uh, things that you need to submit, like quizzes, online homeworks, and all of them can be seen in your CASA calendars. So make sure to always check the CASA calendars for deadlines, like for online quizzes, exams, written homeworks too. So yeah.
I get that, but like, I just meant like the lab class specifically.
I see.
Yeah,
For
sorry
the
about
lab
that.
class, yeah, no problem. For the lab class, basically there would be no assessments or you will not be graded about anything in the lab class. I won't be taking attendance, but again, you are highly encouraged to attend the lab sessions because I guess here is where we will try to supplement whatever you discuss in the lecture. So because we understand that it might be difficult for some, or there might be some unforeseen circumstances that will prevent you from attending the lab sessions all of the time. So that's why I guess that's why we decided not to give some live assessments in the lab meetings. But yeah, still attend this. And if there are cases where you cannot attend the lab sessions, then you can watch the recordings. But yeah, don't worry. There would be no live assessments from here. Everything will happen via the lecture. I guess there would be poppers in the lecture, and the quizzes, the written homeworks, and the exams that you will be submitting via CASA. All right.
I have a question.
Uh-huh.
So basically, this course will not, you won't be taking anything into effect that will affect our our lecture course.
Uh-huh. Yeah, that's correct. So basically, this is designed to be just a supplement for the lecture course. So everything will be discussed in the lecture courses, though there would be a limited time there. So the thing is, we will answer your questions. We'll answer some additional problems for the topics introduced in the lecture. So this is kind of a supplementary course. So the grade for the for the course will be coming from everything that you do in the lecture plus the exams quizzes in CASA. There would be, as far as I know as of today, there would be no grade component coming from the lab. But that might change. I'll let you know when that changes or when we decide to give you some poppers in the lab. But as of today, there would be no assessments in the lab. Okay.
Just one more question. In
Uh-huh.
the lecture today, Professor Almas was just like, there's going to be some sort of tracking going on in the lab. I don't know what she meant by that.
Me neither. I'm not sure about what is tracking. But yeah, if there's some important things that you need to do or you need to submit, I'll remind you or I'll let you know in the lab. But for today, we'll just make the plan is just to make some introductions, and perhaps if time allows, we can start reviewing some things from Calculus 1. But basically, okay, so yeah, let me see the chat. There are some nice points in the chat. Yeah, maybe tracking, she means that, yeah, because the chats are still here. So maybe she wants, maybe she will be tracking the meeting chats that we have. So if you're really participating on this, and also lab meetings are recorded. So she can rewatch it and see if you are really participating in the class. Um, Labs aren't mandatory, but highly encouraged. So as of now, there would be no assessments from the live labs. So there would be no graded components coming from the labs. But so that makes, I guess, that makes it non-mandatory, but it is highly encouraged because based from my experience, usually students really like the labs because that's the time they can ask questions and we can address some of the topics introduced in the lecture in details. So yeah, uh, pre-COVID, students are required to attend the labs during the face-to-face classes because we do give aside from the supplementary discussions, we also give lab quizzes and homeworks are turned in during the labs. But during these days, of course, everything went online and we understand it might be difficult for everybody. So yeah. Okay, nice question, Madison. Yeah, if you have a certain if you have some questions like questions about a certain topic that is covered in the lab, you can send them right away in the meeting chat. It will also it would be helpful if you send them in the meeting chat so I can read them right away. Because if you post it in another channel or in another tab, I might not be able to see it right away. So post your questions or send your screenshots of the questions you have in the meeting chat, because what I'm doing, or my setup right now, is I have my laptop on where I can see the meeting chat and the screen that you are supposed to see. Plus I have my tablet where I do all the writing. So yeah. So send your questions in the meeting chat. If it's an off hour, or if you are doing some problems on your own, trying to answer things, and then you encounter a certain problem, you can send them to me via email. Let me just go back to the worksheet. Yeah, you can send them to me via these email addresses or as a chat in MS Teams. Good question, Faiza. Yeah, I usually do it this way. Every lab meeting, we will be working on a worksheet, a pre-designed worksheet. So I post these worksheets or the blank versions onto the website or the web page, and then during the meeting, I will be answering some questions to some problems on this worksheet. So I'll be working on some of the problems. So I'll write the solutions here, and what I'll do is after the end of the session, I'll upload the annotated version into the website. So this will get updated every now and then. So say for today, we'll answer 5 questions. So at the end of this file, there would be solutions to 5 questions, or probably some questions. I'll upload it into the web page, and I'll call it the annotated versions. And then next Friday, we'll continue on working on this worksheet, and then the annotated version will be updated into the web page. So as we go along, the worksheet, the annotated worksheet, gets updated. So, and then there would be some times wherein if we have, say, a short worksheet, and I was not able to answer all of the questions there, and if I think all the problems are important, I can take extra time and answer everything and upload it as a completed worksheet. So yeah, all files will be available on my website. And what I also do is once I upload something on my website, I also post an announcement into the live lab meeting channel saying that, hey guys, I uploaded the video for today's lecture. You can find it in my website or on this link. Or I uploaded the annotated worksheet into my website, or you can also click this link to get the file. So something like that. So you get notified once I have some things uploaded. Good question, Brian. Lab office hours. I don't have any separate lab office hours, but what I have is my online CASA tutoring hours, but they still haven't given me my attendance yet. So, sorry, I don't have my schedule yet. So, but I guess you are familiar with this for those who took Cal 1 last semester. So you will be added to a CASA tutoring teams in MS Teams, and you can visit that channel any time of the day, or I mean any time of the workday from, I guess, 9 to 5 or 9 to 7 p.m. Every day. There would be some TAs assigned to man the tutoring center. So you can go there, ask your specific questions to the tutor, and my office hours will be devoted on manning the tutoring hours. But as of now, I don't have my schedule yet. I am supposed to have 2 office hours that will be spent in the tutoring center. So I let you know once I have those 2 hours. But if you are not available during those 2 hours every week, so you can go to the online CASA tutoring team any time of the workday, and there would be some TAs assigned to help you with some of your questions, right? And also, if you encounter some problems and you want to address them to me personally outside of the lab meetings or outside of my CASA hours, you can send them to me via chat in MS Teams or via an email, and I'll try to answer as soon as I can.
Hi, I also have one more quick question.
Sure.
So, like, are we gonna get like an overview of the lab? Because I think in my labs last semester, they just told us, hey, we're gonna go over this today, so make sure you have all the materials that are needed and stuff like that.
So, well, what I try to do is, okay, so the format would be usually every week I'll have a worksheet prepared. So you will see it in the website, the blank worksheet. So for instance, for this week, I have worksheet number 1. And you can browse through worksheet number 1 to see what are the things that you need to remember or what are the things to be discussed in the lecture. I don't have any specific routine beforehand aside from preparing the worksheet. The thing is, I want to keep the lab meetings as spontaneous as possible. So though I have some questions embedded in the worksheet that I want to answer during the lab meetings, but feel free to let me know if you have some questions about any topic during the lab so I can address them during the session. So let's keep it as flexible as possible. But basically, I'll follow the calendar of topics given by Dr. Almas that is posted in the CASA page. So, for instance, if today you work on, say, section 6.4 in the lecture, so expect that the lab sessions will be devoted into answering supplementary problems to that section discussed in the lecture. All right, I hope that answers your question, Rohail. There's a question from the chat coming from Christina. Yeah, are we? She's asking whether we are going to be able to go over quiz questions or homework here. Definitely yes. So this is the avenue for you guys to ask your questions about quiz problems or homework questions. So just send them to me via chat, via the meeting chat, so I can see them right away. So if you are trying a quiz problem, you tried it a couple of times and you still get the wrong answer, so you can send them to me so I can discuss them either privately with you in a chat, in a series of emails or chats in MS Team, or if I think it would be helpful for the entire class, I can address it in the lab meeting. Yeah, don't hesitate to send me your questions, be it from the quiz questions, practice test, homeworks, etc. I'll try to answer them the best I can. It will also be great if you can send them to me kind of a couple of hours in advance. So because there are some questions like quiz problems or homework problems that I don't want to answer as is, meaning you send me a question and this is for homework. I might not want to answer the problem, the exact problem, because that would be graded, but I will try to answer a very similar one. So it will be great if you can send them to me in advance so I can sort of modify the question a bit, but I'll keep the spirit of the question in there to guide you in answering that homework problem. Otherwise, I'll just invent something on the fly. But yeah, so it will be great if you can send them to me in advance. Okay. All right. Any other questions about the housekeeping preliminaries? I don't have specific rules for the lab, so I just encourage you to participate via the meeting chat. You can unmute yourself from time to time if you want to say something or ask a question. So I'll be happy to address them. Again, don't hesitate to ask questions. For me, there are no dumb, stupid, or naive questions. Just keep them coming. All right. Any other questions?
So if we have a question for based on in the lectures, we can just email them to you if like we didn't ask you in the lab time, and you would answer through email.
Right. Yeah. I'll try to answer as soon as I can via email. So yeah. And if again your question is very interesting that I think it's worthwhile to discuss it in the lab, I'll do so. Yeah. So yeah, I guess the thing is I want the lab to be okay. Hello guys, sorry about that. I think I was cut off. Okay, is it better now?
Yeah, it's back to normal.
Okay, yeah, sorry about that. I guess few glitches with MS Teams. Let me just restart sharing my screen. And where was I?
We can see your screen already.
Okay, you can see my screen. Okay, there we go. Because I was I'm looking at my laptop and I'm not seeing anything. So yeah. Okay. Where was I? I forgot what I was talking about. Yeah. So okay. Any other housekeeping questions? So we still have about 15 minutes left for the class. So if you don't have any questions, maybe we can get started with worksheet number 1. Okay, so right, so let's try this. Section 6.2. So section 6.2, and I guess the next covers or section 6.2 encompasses questions 1 to 4, and then section 6.3 actually, yeah, 1 to 11, and then section 6.3 and so on. So these are things that you were supposed to remember from 1431, but we went on a long break, so probably you forgot some of these things. So basically, maybe I can start with the first 4 problems or some of them for the next 14 minutes of this class, and then next meeting we'll continue with some problems from section 6.4. All right, is that fine? Unless you feel very comfortable with section 6.2. But anyway, section 6.2 tackles the fundamental theorem of calculus. So I hope you guys can read my penmanship. Okay. So the fundamental calculus consists of two parts. The first statement basically relates derivatives and integrals with each other. So basically, it reveals to us that derivatives are simply the inverse process of integrals. Basically, if you have a function defined in terms of an integral, so if you have an integral of integral from a to x of some function little f of t dt, right? And you want to take its derivative, it tells us that the derivative of that integral function is simply f of x, right? And let's take a closer look with this. Now, what are the requirements for the first part of the fundamental theorem to be applicable to a certain problem? Well, check the lower bound of integration. The lower bound should always be a constant, all right? So it should be a constant. Next is that the upper bound should be a variable or a function. And if that variable matches the variable of differentiation here, then basically these two operators here will simply cancel each other out, leaving us with the integrand or the input function, which is little f as our answer, but evaluated at the upper variable. Okay, so an example to this is if we want to integrate or to find a derivative of say from 0 to x of say sine t over t squared plus 1 dt, right? Oh, by the way, this would be my convention for this particular worksheet. If I invent an example on the fly, meaning it's not included in the problems from the worksheet, I'll use a letter to label it just for easy reference. So this is example A. This is not from the worksheet problems. That's why I'll label it with a letter. And then if it's a problem coming from this worksheet, I'll label it with appropriate number or with the corresponding number. Okay, just for easy reference. Okay, so let's see if the first fundamental theorem applies directly here. So the lower bound is a constant 0. That's fine. The upper limit is x, which is the same as the variable of differentiation. So that means these two operators are inverses of each other. So they will sort of just cancel each other out. So basically, what will be left would be the integrand, which is, if you remember, the function inside the derivative, inside the integral, but evaluated at the upper bound. So instead of the variable t, I'll use the upper limit. So here, I'm going to have sine x over x squared plus 1. And that's the final answer. So basically what happened here is that the derivative and the integral operator canceled each other out, leaving you with the integrand, but evaluated at the new variable. Okay. But there would be some cases wherein the upper limit doesn't match the variable of differentiation. For instance, I want to differentiate with respect to the variable x, but the function given is the integral from say 1 to x squared of say tangent of t dt. All right. So here, let me change the tangent to a cosine instead. Okay. All right. So here, if you do the quick check, if the fundamental theorem applies right away, the lower bound is a constant, so that's a check. But the upper bound is x squared, which is different from the variable of differentiation, so they don't match. But it's not a big problem. All you need to do is copy the integrand, evaluate it at the upper bound nevertheless, right? So instead of a cosine t, I'll have a cosine x squared. But remember that we noticed that this upper bound doesn't match with the variable of integration. So whenever that happens, we need to multiply whatever we got so far by the derivative of the upper limit. The upper limit is x squared, so its derivative is 2x. So basically, that's, if you remember, that's the chain rule, basically, right? So whenever the upper limit doesn't match the variable of differentiation, carry on with the application of the fundamental theorem, but don't forget to introduce an extra factor due to the chain rule, which tells us we need to multiply what we got by plugging in the upper limit by the derivative of the upper limit. All right. So I'm just presenting to you the mechanical solution. The theory and the details why we do that, I hope, was discussed in more details in your previous classes in 1431. So that's the reason behind doing this is basically the chain rule, but it should have been discussed in more details in 1431. So I won't go over that unless you want me to. All right. Okay, so let's look at a couple of problems from the worksheet itself covering that topic. So perhaps let's try, okay, let's try problem 1 from the worksheet. So I'll be labeling it problem number 1. So we have integral from 1 to 4x squared of cosine t dt. And we need to find capital F of 1, of basically, this is the function big F of x equals that. And we need to evaluate F of 1 and F prime of x, right? So first, we solve for F of 1, right? How do we compute F of 1? Well, all we need to do is to plug in 1 for every x's that we see in the function f, right? So here the function f is the integral from 1 to 4x squared. But instead of a 4x squared, I'll have 4 times 1 squared cosine t dt, right? So this would be integral from 1 to 4 of cosine t dt. Right? And then if you remember the second fundamental theorem, did I copy the problem correctly? Yeah, I'm thinking this might not be the intentional problem, but anyway. So here, if you remember, what's the antiderivative of cosine t? The antiderivative is sine, right? So this would be sine of t. What was differentiated in order to get cosine? We need to differentiate sine. And the second part of the fundamental theorem tells us to evaluate it from 1 to 4. So basically, this would be sine of 4 minus sine of 1. Unfortunately, we don't know the exact value of sine 4 and sine 1, so we just keep it like that. So this first part of the solution is basically just plugging in x equals 1. All right. But the second part is basically the application of the fundamental theorem, because for the second part, we need to find capital F prime of x. But F prime is simply the derivative of f. And big F is given to be the integral from 1 to 4x squared of cosine t dt. All right. Here, we check if we can apply the first fundamental theorem. Lower bound is a constant, upper bound is a function, but it doesn't match the variable of differentiation. So keep in mind, we need to apply the chain rule here. So basically what we do, copy the integrand, but evaluate it at the upper limit, 4x squared, times the derivative of the upper limit. The upper limit is 4x squared, the derivative is 8x. So this is our final answer. Okay, all good, everyone? Okay, thank you, Marian, Fatuma. Yeah, I'll appreciate it if you give me some feedback in the chat, so I know that I can go on and everything seems clear. Also, let me know if I'm going too fast or too slow. I have the tendency to go very slow because I'm including everything, all of the details in the solution. So yeah, I usually go slow, but if it's too slow for you, just let me know. I can pick up the pace. All right. All right, let's answer another one. So let's start with probably problem 3. Problem 3 is similar to problem number 2, so I'll address problem 3 instead. So capital F is given to be the integral from x squared to sine x of the square root of 1 plus t dt. And we need to find capital F prime of x. Okay, so here we need to find f prime, but remember f prime is simply the derivative of the given function. Oops, that's not what I want. Okay, so simply need to differentiate this. If we check if we can apply the fundamental theorem, we'll realize there's a big problem here. Lower bound is a variable. Upper bound is also a variable, or it's also a function. So, but remember, the fundamental theorem requires one of the bounds to be a constant. So it seems that we have a big problem here because, yeah, we don't have a constant limit or a constant bound here. But we can apply some properties of the derivative in order to address this issue, or actually property of integral. Here, we need to differentiate, but what I'll do is I'll split the integral up. Basically, you can interpret this to be integrating starting from x squared until sine x. But we need a constant bound, right? So let's just invent a constant bound. So I'll still start the integration from x squared, but I'll cut it off at some number, say 0. You can pick your favorite number as the subdivision point here. So instead of integrating straight from x squared to sine x, I'm going to cut the integration at a number, say 0, right? So the first integral will be that, plus I'll carry on the integration. Now starting from 0, that's where I left off, right? Until sine x, which is the upper limit there. So basically, you can interpret this as performing a pause in the integration. Instead of a straightforward integration from x squared to sine x, I'm going to first integrate from x squared until 0. I take a pause and evaluate that integral first, and then add to it the integral starting from 0 until the determined endpoint sine x, right? And that's perfectly valid. I think you have seen this in Cal 1, this property of splitting the integral up into several pieces. And these things will share, or these two integrals will share the same integrand. So we'll have this, and we'll have this. All right. And the only reason that I did that is for me to have a constant bound, right? So basically, now I apply a property of derivatives. Remember, I can take the derivative of a sum as the sum of derivatives. So I'll split the differentiation into 2 parts, right? And differentiate or perform the derivatives for each of the 2 integrals, right? So that's the additive property of derivatives. Now I have a bit of a problem with the first integral, with the first term, because here the lower bound is not constant. The upper bound is a constant instead. But there's a trick that we can use here. Remember, we can reverse the order of integration. Instead of integrating from x squared to 0, I'm going to integrate from 0 to x squared. But do you guys remember what's the cost of doing that?
Turn it to a negative.
Kevin, thank you for that. You're correct. I'll put a negative sign there, right? So whenever you're reversing the order of integration, I mean interchanging the lower and the upper limits, that comes with a cost, and that's introducing a negative sign in front, right? And now I guess we're good to go. I'll just copy everything here. And there we go. And then now I can evaluate each of the derivatives, each of the terms, using the fundamental theorem. So basically, I have the negative sign carried over, and then I have a constant here. I have a function here which doesn't match the variable of differentiation. So I know here that I need to use the chain rule. But how do I do that? So I copy the integrand, but evaluate it at the upper limit. So 1 instead of t, I'll plug in x squared. But chain rule dictates I need to multiply it by the derivative of the upper limit, right? Plus, Lower bound is a constant. Upper bound is a function, which is different from the variable of integration. So keep in mind, I need to use the chain rule. But how do I do that? Again, I copy the integrand, but evaluate it instead of the variable t. I'll evaluate it at the upper limit, which is sine x. Then chain rule kicks in. I need to multiply it by the derivative of the upper bound. The upper bound is sine x. The derivative is cosine x. And that's it. That's my final answer. That's f prime of x. Okay, I hope that's clear. Any questions to that, guys? Yeah, I thought I'll be able to answer problem number 4, but maybe we can reserve problem number 4 for the start of Friday's meeting. But what's a t squared? What's a t squared, Kevin? Did I miscopy anything? Yeah, I guess that's it. Yeah, let me see. I don't think I missed an a t squared here. Okay, so okay, so that's it probably for today. So what I advise you to do is take a look at the rest of the worksheet. Next meeting, I'm going to start with problem 4. I think it's interesting. It will give us some insights how to work with integrals and the fundamental theorem more. And then I suggest you take a look at problems 5 until 19 of the worksheet. These are basic derivative integration problems. So for these problems, you just need to remember the derivative tables and the integral tables or integral formulas and the basic properties we learned from 1432. So I won't focus much on these problems unless you think there are some hard problems on here. So I'm thinking to leave these problems to you guys. But again, if you find some difficult ones, let me know. I can briefly go through them on Friday. What I want to focus on next meeting would be on problems coming from section 6.4. So that's problem 20 until 56. These problems requires U substitution in performing the integration. So I want you guys to take a look at them and try to answer some of them. And if you find something interesting or some problems interesting or some things difficult, so take note of them and then let me know so that I can focus on those problems. But usually I start with the easier ones just to set the tone. I start with an easy example and then go to the more interesting ones as we go along in the discussion. So yeah. So let me know on that. And then in say half an hour or an hour, I'm gonna upload this this worksheet or this version of the worksheet with sort of this with the problems we solved today. And I'll also do the same thing on Friday. I hope we can answer more problems, so you can download the annotated worksheets from there. Just a heads up, I might not upload a completed worksheet 1 because there's a lot of problems here and we won't be going through all of them. So yeah, but let me know if you want some problems to be included in the final version of the annotated worksheet. All right, guys. Sorry, I extended by 5 minutes because I was supposed to dismiss you at 12:50. But yeah, do you have any quick questions before we call it a day? Yeah, lab is 3 times a week, 12 to 1 from every Monday, Wednesday, and Friday. Okay, so if you don't have any questions, then I hope to see you guys again on Friday. Have a good one, everybody. Bye.